um, that's meant to, it's a spec for querying an API. So let's just dive in. And by the way, I thought this talk was 10 minutes longer than I've got, so we might hurry. And this is not the beginning. Okay, so this is me. I'm Dustin Whitney. I organize the New York Scala meetup. If you ever want to do a talk in New York, let me know. I'm also one of the organizers at the New York Scala Symposium. I used to be the CTO of Pollution Analytics. Now I'm at Project September. I work with some awesome people. We have an open source library called Freak. It's a library for working with, it takes a lot of the boilerplate out of working with free monads. A guy named Pascal Watteau or Mandubian put it together. Another guy named Gaetan Renato put together some libraries called GLReact, GLReact Native, and he worked with another person I work with named Mr. Speaker. You should check these libraries out. They're really awesome. It enables WebGL through React. So we're here to talk about GraphQL, and I just wanted to set, I don't know, the way I like to at least hear talks or give them is set up a problem and then try and understand how to solve it. So I've been doing a lot of work in startups pretty much since like 2007 or something like that. So I'm going to give this talk from that context, and not everybody works at a startup, so you know it won't be 100% germane to your situation, but hopefully you can learn something from it. And I certainly don't want to stand up here and say this is the only way to do it, because there's a bunch of ways. From my perspective, people are the hardest thing at any startup easily. And like, let's set aside personality issues and just focus on actually just hiring some people. You're about to set off on this adventure. You may or may not have a lot of money, and now I've got to go find a bunch of people who are ready to just drop everything and go take this journey with you. And of course, you're going to be working with a CEO who wants everything. They want a website, they want an iOS app, they want an Android app, and now, of course, they want an Electron app. So you're going to need some way to, and then on top of that, you're going to have these 4 different things. They all need to be put out into a production server, and you need to feel pretty good about it. So that's a lot. That's a lot to take on. And when I think about that, when I'm going to go find these people to work on this team, your iOS guy probably only knows iOS. Your Android guy probably only really knows Android. Your web guy might not know iOS or Android. It's a tough problem to solve. I got to go find these 3 people just to work on this one small project. And then I've got the DevOps problem and the back-end problem in addition to that. If you're like me, you're probably better at that and feel a little bit more confident about it. So there's these other aspects that are a little bit tougher. So I think some good solves are coming out of Facebook right now. Facebook's doing some amazing stuff. I think React, React Native, and Relay really address the issue of solving those first 3 people that you have to hire. If you can find a really, really solid React Native guy, he could build your iOS and Android app and your web app. And probably, I mean, it depends on how flexible the non-tech part of your team is, but you could probably get like 90% shared code between all these different platforms, and they'll feel very native. Your entire interface can basically be built, and then you've got to, you know, if you're going to do payments, you're going to have to do your Apple Pay separately and your Google Wallet separately. But you're probably going to be able to find somebody who's solid enough engineer that they can figure out how to make that work on iOS and figure out how to make that work on Android. So these are some great solutions to solve that end of things. The other side is the DevOps and backend, and definitely some solutions that I like to solve this people problem. Well, where am I going to get all these people? And I can't really afford very many. I guess I want to start with AWS Lambda. I haven't actually used it, but I find it very attractive in the sense that on the server, I can just kind of let it run. And I think GraphQL which we'll definitely get into, it fits very nicely into AWS Lambda, because if I'm going to launch a web serving thing on AWS Lambda and I'm using REST, then every single endpoint that I create, I'm going to have to manage through what they call an API gateway. And it's just going to be kind of painful. And again, you're a startup, you're trying to work as fast as you possibly can. I don't want to deal with this weird setup. What you'll find with GraphQL is there's really only two endpoints. You're going to have an endpoint to serve up your schema, we'll get to that, and an endpoint to take queries. And then you're kind of done. So just putting this thing out there is pretty simple. In fact, just anecdotally, at Project September, I think we've changed out our web backend 3 different times. We've had Play, we've had Finch, and now we're on HTTP4S. One day just to switch from each one. Really easy. I think we have 6 endpoints, something like that. So I talked about the inversion of control. So, I mean, probably if you're like me and you've been around a while, the first thing that comes to your mind is Spring, because everyone just thinks of dependency injection. It's probably the opposite of that now. What I basically mean is just taking the way things are and inverting it. So the way things are, this picture is meant to represent the way things are. We've got a mobile device and a desktop device, and then the URLs are meant to represent an API. And then the lightning bolt says, this API serves these 2 devices. And I've segmented the API up into what I would call 2 different problems. So the top API just shows me fetching everything from one single endpoint. And that might work well in the beginning of your tiny little startup when you don't have much data and the app doesn't do a lot. And it's easy. So I can just make this one query and I get everything for our user here, Odersky. That's eventually going to fall apart. So you then break up the endpoints into many endpoints that fetch various different things. And that might work well on your desktop that has a very steady connection with a lot of bandwidth. But your mobile device might fall apart on that, especially if you're making a lot of requests. So you'll get that weird state where maybe not even all your requests are failing, but some of them are just slow. So your pages can render kind of poorly or just not at all. And this is, I don't know, just a tough issue that your front-end developer is going to have to come to. And what you're going to end up doing is basically building kind of 2 backends, one that serves your mobile app to accommodate for its needs, and another that serves for your desktop app that accommodates its needs. So GraphQL solves this problem by essentially letting you query your API and fetch only the data that you need. So if I have a mobile device and it has some performance requirements that need to work with a shady connection, I can ask for just the data that I need to render a screen that will look good in that type of environment. And conversely, with the desktop, I can get everything I want all at once. And the backend doesn't have to change anything. They just need to expose a schema and an endpoint to take in a query. And then your front end and your back end and your mobile developer and your desktop developer, hopefully they're the same person, can experiment with different queries to see what is more appropriate for the product that they're building. Anyway, so let's get more into what is GraphQL. So I've talked a lot about a schema and querying that schema. So immediately the first thing that came to my mind when I heard about it, and it comes to everybody's mind, is this sounds like some kind of a database. It is not a database. It is simply a way to query your API. You're not going to change the way you code very much at all. But it is easy to use a database as a good way to explain what it is. So I've got some SQL over here. It shows creating a table. You all know what that does. And then over here, I'm selecting some stuff from this table. The equivalent down here is GraphQL. I'm creating a user type, and it's got a username. And I'll get more into this later. With GraphQL, as the name implies, you're traversing a graph, an object graph. So I need a way in. So this root is my way in. So over here, I'm executing a query. It looks a lot like JSON. It looks like basically the left half of JSON. And then here's the response, which is JSON. So that's GraphQL in a nutshell. Like, you're basically making a schema. It's a type system that maps pretty closely to Scala, not exactly, but close enough. And then some JSON at the other end. Okay, so let's talk more about what these schemas can look like. So the different types that you can create in schemas are, you've got object types and fields. So just starting here, I've got a user type. It has a username. It's got a string, which is of type string. There's an exclamation point after it. That just means that it's not null, so it's required. I've got a comments field attached to this user, so maybe I can fetch some comments this user created. And it's in brackets. That means it's a list. It also does not have the exclamation point, so that means it might be null if you get it, if you query for that. Again, here's my root. It accepts arguments. So think of this like a method on an object. So I have a user method. It accepts a username, which is required, and it will return a user. Down here, you have this query and mutation. So this thing is basically required in every GraphQL schema. It's basically saying this is how you get in. So I have a query field, and it's of type root. So my way in is through the schema, and I have a query field, type root. And then GraphQL segments queries, so reads from writes. So it has queries and then mutations. I'm not going to go too in-depth into mutations because I don't have a ton of time. But and there's really nothing forcing you from side effecting inside the query nodes if you want, because it's going to hit your code. You can do whatever you want. But you ought to adapt this model where only mutations happen through the mutation part of your query. And of course, read the docs to understand that more, or talk to me after. We've got some enumeration types, interfaces. These, it's just like a trait. You can attach it to something, and then you can ask for something of a type mammal. And then there's some query syntax for how to treat data should it be a particular instance of that mammal. So that's all there. Again, not going to go too into depth. And then there's some union types. So these are all of your building blocks for creating a query that you can query against and express to your user in GraphQL. So how do I do it in Scala? So let's build a little test app here. I've got a user and an avatar, and an avatar repository that has a method called getAvatar that accepts a username and returns an optional avatar, and a user repository that has a method called getUser that takes a username and returns an optional user. So this very standard looking Scala code. I'm going to map it over to this schema here. This is my GraphQL schema. You'll notice some differences. My user does not have a field called avatar, but I'm going to add it to my schema. So I'm going to create an object graph. And I'm going to have some things in that you will be able to traverse without having to call a service in this way. So we're going to explore how I add this thing. My avatar is very straightforward. It has exactly the same fields. And then again, here's my root. So this is how I get into the object graph. So I can basically just query for a user. So that's the model and the schema. We're going to try and execute this query. So basically, I want to pull the user Odersky out. I want his username, and I want the mobile optimized URL, so for his avatar. So basically, some low-quality image that loads very quickly. So roughly what I'm trying to say here is maybe I'm building an app for a mobile device, and I don't want to get all the other data. I want to get specifically the data that I need. And then the query will look just like this. So your GraphQL actually don't know if it's required that it return data. It might be. It is if you use Sangria, which is the Scala version of Scala implementation of the spec. And you'll get a field called data, you'll get one called errors. Anyway, it's just gonna return exactly the data that you'd expect. Okay, so I just wanted to start with, here's some very regular looking Scala code. Everyone loves to hate the cake pattern. I used it anyway because everybody knows how it works. So there you go. Here's the cake. I got a little database here with Martin Odersky in it, and one for avatars, then an implementation of my 2 different repositories to get the avatars out. So very regular looking Scala code that you write every day, and we're just going to use that in our GraphQL. Okay, so now how do I map my different types into a GraphQL schema? So we walked through this very quickly already, but I have an avatar. I want to make this case class that's an avatar into a GraphQL object type that is an avatar. So this is the code to perform that. I parameterize it with 2 types. I declare an object type. I give it a cake, which I'll use later. I'm going to explain more how the fields in the objects work on the next slide. And then I give it another type, which is the type this object is meant to represent. And then here's my URL field. It has a string type. Here's my mobile optimized URL. It's also a string type. I have this resolve function in both of these. And you'll see it, I'm hitting this value argument, which is pulling the fields off of this type of URL. I hope this becomes more clear on the next slide. This is how you create all the different object types to map your different case classes into GraphQL. And they'll look just like this. So we saw this on a previous slide. This is a lot of boilerplate. So the preferable way to do it is down here. There's some macros to very quickly, macros to do exactly the same thing in a single line. And then of course there's ways to update those fields that are derived. So more about fields. Okay, so we created our avatar type on the previous slide. Now I want to do my user type, but if you'll recall earlier in the talk, I said I wanted to add another field that was called avatars. So we want to traverse this graph. Avatars doesn't exist on my case class and users. So I'm going to add it myself. And I do that, I'm going to derive the object with the macro. But again, because it doesn't have the avatar type, I just need to add a field. So to the derived type. So I just add this in here. Again, read the Sangria docs. I hope I may have passed over my slide about Sangria. Sangria is the Scala implementation of the GraphQL spec that was created by a guy named @EasyAngel on Twitter. He's done an amazing job. It's like an excellent piece of software. Anyway, let's get back to this field. So I'm adding a field called avatar. It is of type avatar object, which was declared on the previous slide. The field has this resolve function, and I've given it a type. I've annotated its type here just so you can see what it is. It is of type context, and then again, it's parameterized with the cake and the user, because I am working with the user field. And basically what happens is when a query hits your server or whatever you're using to resolve these queries, it's going to pass in a context into this function when it gets to resolving that part of your query. And you will then use this to build that particular part of your object graph. So right here, well, it's worth looking down here at the context. So this is what the context looks like. There's a lot of interesting fields on it, but the ones that you'll use the most are value, CTX, and args. And value is, again, this parameter, which is user here. And CTX, it's my cake. So all of the stuff that I need to get things out of my database or fetch them from wherever, it's going to be in this cake. So then when this function is called, I'm using the context that's populated with the things I wanted to just fetch my things out. So I just think of it as a cake that gets passed around. I have never actually used just a straight up cake in production. We have a thing we call a GraphQL context. It has a cakey-like thing in it as a field, but you can make it whatever you want. So I don't know why we don't do this, but I've often thought it would be great if we stuck the request object in there. So if we receive an HTTP request, we have the request. If there were files in that request, we could get the files out. And for some stupid reason, we just read the files out, and then there's a file field that you can pull the file out. But anyway, so you can make it whatever you want to pass in there. So this is how it basically works. And I hope that demystifies fields a bit. How much time do I have? 1 minute. Okay, we're going to do a demo. Okay, this is called graphical. You can see it. Good. So this is basically like a query analyzer that Facebook has put together. You can basically load up a query and execute it against and execute queries against a schema. Sorry, you can load up a schema and execute queries against the schema. So Hacker News has a GraphQL endpoint, and we're executing a query against it. Now, what is cool is you can basically use this docs thing to just sort of figure out how to write a query. So this is, it looks like I could query GitHub. So why not? Let's see what Miles Sabin is doing. GitHub, it's got all the query completion stuff you'd want. User name. I don't have this API memorized. And you just don't need to, which is cool. You just kind of click around. Let's get his repos. GitHub repo, and let's get the names. Name. And then run. And there we go. There are Miles Sabin's repos. I wanted to do this. Maybe I should have even started with this. I think this to me is the selling point right here. It's just all these tools exist on the front end for your developers. Every query they execute can be validated against this query. I don't even have to read the documentation on these APIs. I can just kind of use this query analyzer to figure them out. We've had a lot of success with it. We've been running it for 6 months. If I started over, I would do this again. No question. Yeah.
So I guess the only question I have here is how do you get authentication with things like
do it externally. Do it in your HTTP client, and then stuff it into your GraphQL context. So you'll have a user, stuff your user into that authenticated user into that object that I was passing around like my cake.
And limits the data, like this user can only see these things here and not these.
It'll just be a part of your logic inside of the GraphQL. I can show you some concrete examples of how we're doing it. I'd actually be interested to see how other people are doing it. But there's actually a section on the Sangria site to discuss such a thing.
Okay. What about authorization if you want to give access to some people to one field but not the other?
Okay, we got to go, but I will talk to you after. All right, thanks.